Hello, today we're going to learn how to graph linear equations. And before we jump into actually graphing, we're going to get a little bit of vocab out of our way. So what we have here is what we call the Cartesian plane. And you might be noticing it's broken up into 4 squares, in which we have a line that goes horizontally through it called the x-axis, and a vertical axis, which is called the y-axis. These two axes break this up into 4 pieces, in which we have what we call quadrant 1. And we usually use the Roman numeral to denote it. And if you want to shorthand it, you can write Q. This next one is called quadrant 2. And we'll go below and we're in quadrant 3. And last but not least, we're in quadrant 4. So here's our 4 quadrants. Now, everyone starts where the y-axis and the x-axis intersect. So this point right here, this is where we say is the beginning, or we call it the origin. And the origin is set at a point 0, 0. So what you have here is an x-coordinate and a y-coordinate. At this point, where the origin, where they intersect, x is 0, so that represents with that x being 0, and y is also 0. X is always first whenever we talk about an ordered pair. So let me quickly write that off to the side. What we call an ordered pair is usually a point in which we have x comma y. If we are in quadrant 1, our ordered pairs are very nice. Like you can see, here's 1, 2, 3, 4, 5, keep on going across your x-axis. And the same deal with going with the y's. When you go up, you got 1, 2, 3, 4, 5. And if I were to plot a point here, this might not have been my best choice, but yeah, let me quickly decide a different one. Let's say we had a point here. Just shifted over one. So we first look to the x-coordinate to describe this point. We have it at 1, 2, 3, 4. So it lines up with 4. So when we write an ordered pair, we'll start with the x first. It's positive 4. And when we go up 1, 2, 3, 4, 5, we have a y of 5. So there's our ordered pair. And notice they're both positive. In fact, we are in quadrant 1, in which both the x is always positive, and I'm just going to fix that real quick, and the y is always positive. So life is beautiful. Everything's positive in quadrant 1. So that's why we start here, if you were wondering why we stopped at the upper right corner. Now, quadrant 2, we shift over to it because now, if you notice, we go to the left on the x-axis. And when we go to the left on a number line, usually that says we're getting smaller or we're headed towards the negatives. We still have the positives for the y-axis though. So if we were to want to represent a point, maybe right here, I went over 1, 2, 3, 4, 5, 6. I'm at negative 6. And I'm at positive 3. So x is still first and then y. So quadrant 2 is nice, in which we have x is negative and y is always positive. And you probably can be guessing what's going on in quadrant 3, in which the y's are also negative. So maybe I have a point way down over here. So I'm at negative 2 for the x. And the y's are at 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. So quadrant 3 has both coordinates being negative. And then last but not least, we have quadrant 4, in which the x is positive, as you can still see here, and the y is negative. So points are just little dots on our plane. They're always an ordered pair associated with them, in which x is before the y. We can describe where points are located by the quadrants. And our starting point is always at the origin. So let's go ahead and have it where we're asked to plot points. So we're going to plot the following points on the same graph. And I've given names to the points so they're a little bit easier to differentiate between them. The first point we have to plot is A. So I'm going to use blue for A. So we have 3, 4. X is always first, then Y for our coordinate system. And this is how we would always operate. Unless you work with a different labeling, there's almost always alphabetical order. So you start with X, then Y. So find yourself at the origin. That's a good place to start. Now our X coordinate is 3, positive 3. So that means we go to the right, 1, 2, 3. Excuse me. And now hover. Okay, don't draw a point yet. So hover at that X is 3. Now Y is positive 4. So we'll go up 1, 2, 3, 4. And we'll find ourselves at a nice point, and we're going to label him A. You can also label him by writing 3, 4 right next door to him. That way it's clear what point you intended. Alright, let's try another one. I'm going to do point B. I'll call him red. So, we have negative 4, 6. So start at the origin. That's our starting point, origin, like the beginning of time, origin stories. So here we begin. Now, we go to X coordinate first, always. So X is negative 4. So from the origin, we have a negative, so that means we go to the left, 1, 2, 3, 4. Okay, now hover, don't draw a point yet, so just kind of keep your pencil there. And now we're going to the Y coordinate, which is 6. So we go up 1, 2, 3, 4, 5, 6. And there's our point B. So always X first, then Y. Pretty much what you can think of is X denotes horizontal movement along that X-axis, and the Y denotes vertical movement along the Y-axis. And the signs just tell you to go up, down, or left, right, depending on what you're working with. So let's see C again. We are going to use purple for this one. I have negative 2, negative 1. So X is always first, no matter what, and then Y. So start at the origin. You have negative 2 for your X, so that means go to the left 2. So 1, 2. And I'm sorry, I did not mean to draw a little point there. So hover at negative 2. And now we go to negative 1, which is just south 1 more, and there is point C. And last but not least, let's go ahead and do D, which we'll use green. It's positive 1, negative 4. X is always first, then Y. So we'll start at the origin. We'll go to positive 1 for the X. Okay, so here's positive 1. And I've hovered, tapped it too much. So don't make a mark, just stay there. And now go to negative 4. So we have to go down 1, 2, 3, 4. And there's our nice point, D. Alright, so let's just play a little bit of trivia. A, what quadrant is he in? Yep, quadrant 1. And let's see, I don't know, I like C now. What quadrant is C in? Well, both points are negative, so he must be in quadrant 3. How about B? Well, X is negative, Y is positive, he's in quadrant 2. And then, I didn't draw 2, but I meant to. And then, last but not least, this guy has to be in quadrant 4. Alrighty, so that's pretty nice. So that's how we plot points. X first, then Y. Let's go backwards. Let's say we have a graph in which I want you to take the point I've graphed and tell me its ordered pair. So find the ordered pairs of the points on the graph. We'll start with M. So, look at M. He's a little bit tricky. So X is always first. Well, what I'm going to do, and I'm going to kind of draw a dashed line down. So I'm looking at it, what is the X value at this point? Well, it's 0. So my ordered pair, I start with X, is 0. I know it seems funky, but that's the X value there. Now, let's go to the Y value. Well, it's already sitting on the Y value, so let me erase this dashed line. It's kind of blocking the view, right? So let's see, we got to figure out what this point's at. Well, I go up 1, 2, 3, 4, 5, 6. So it's at positive 6. So that's where M is at, 0, 6. Now you might be wondering, well, what quadrant are you in? Are you in quadrant 1, or are you on quadrant 2, or you're on the line? It looks like I don't know what you're talking about. Well, when we are directly on the y-axis, where you're sitting on it, you're not in a quadrant, you're actually a y-intercept, in which you're sitting on the y-axis. It's intercepting it, it's set there. Crosses the y-axis, another way you could say it. So whenever there's a point directly on the y, that's a y-intercept. And now I'm going to cheat real quick. Let's go visit F, because he's a little bit more funky. When we look at him, we're sitting on the x-axis. So let's see, x is always first. We need to find where he's located on the x-axis. Well, we'll start at the origin. We go 1, 2, 3, 4, 5, 6, 7. He's at negative 7 because we went to the left. So we had to move to the left 7. And now we don't move anywhere. We stay where we're located. So we don't have any change in y. We're staying where we are at. The y value is 0. So you can think about it in movement. Let me go back to M and verbalize it a little bit differently. So I start at the origin. Do I move left or right? No, so x is 0. I didn't have any horizontal movement. But let me go up. 1, 2, 3, 4, 5, 6. Oh, I had vertical movement and it was positive, so that's why I have y is 6. Alright, back to F now, okay? So, kind of getting the idea a little bit. If we're at the x-axis, this F here is crossing it. We'll call him the x-intercept. And now let's do G. He's much nicer. So let's see. From G, well, let's start at the origin and try to work our way to G. So, first x. I got to move over 1, 2 to the right, so we have a positive 2. And then we have to go down 1, 2, 3, so we have negative 3. So there we are. And what quadrant is he in? Yep, quadrant 4. So, not too bad. Okay, now that we know how to plot points and go backwards, if they give us points, we can find the ordered pair. Let's talk a little bit more about linear equations, because that was what this whole chapter is about. Linear equations have infinite solutions. That seems a little bit funky. What I mean by a linear equation is something similar to this example I have below. 2x minus y equals 6. This is what we call a linear equation. And what this question particularly is asking us to do is find whether if 2, negative 2 is a solution of it. Pretty much, when they give us an ordered pair, it always follows alphabetical order. So we have x and y here. X is first, then y. And we're being asked if this ordered pair is a solution. It's kind of fancy talk for plug and chug. We have normally 2x minus y equals 6. Now, instead of x, I'm going to plug in what x coordinate is 2. And instead of y, I'm going to plug in the y coordinate, which is negative 2. And now I'm asking, is this true? I want to know whether it's a solution. And if you go back to really far back, I think chapter 10, there was what we defined as solutions. Solutions make the statement true. Any replacement for a variable that makes the statement true. So, we're going to go ahead and say, okay, simplify this. What's 2 times 2? 4. Minus a negative 2. Well, when I subtract a negative, I add a positive. And 4 plus 2 is 6, and sure enough, 6 equals 6, so our answer is yes. This point 2, negative 2 is a solution. And I'm going to shorthand solution to SOL. So, linear equations have infinite solutions. Let's go back to that crazy statement we made earlier. That means there's a bunch of these points. I can't even list off how many points that we could plug into this equation and have it work out. we could try, offhand, and because I know it is a solution, we could try 0, -6. He is also a solution. And this is just a hypothetical situation, so I already answered the question. Just going crazy now. So 0, 6. Well, 2 times 0 minus y. Well, y is -6. And I'm checking if that equals 6. Well, 2 times 0 is still 0. Minus a negative is a positive. Sure enough, 6 equals 6. So this is another solution. And I'm sure you could think of at least 20 more if you really felt like it. In fact, you'd be going on forever because there's infinite, so many solutions to this linear equation. Now, because there are so many solutions, what we're going to do is try to graph all the solutions. And now you're probably crying because you're like, oh my god, I have to find all of them? You just told me there's infinite and I will never find all of them. What we're going to do is we're going to graph it where we'll give an approximation where we'll show if you continue on in this fashion, these are all the solutions. Let's go ahead and do it instead of talking about it. So let's graph the equation 2x minus y equals 6. Notice it's the same equation. Now there's several methods out there. This first method that we are going to do is called guess and check. Pretty much I'm making up any point out there and I'm going to try to see if it works. But I'm going to do it a little bit clever. I'm going to pick x's, plug it into this equation and solve for a y. That way I'll find a y that I know works because I solved for it, and that way I'll have a point. And then I'm going to take these points and plot them on a graph. So let's see. I'm going to pick a random x. I can't stress that enough. I'm just picking this x out of nowhere. I'm going to say -2. And I'm going to take this -2. So I have 2 times x minus y equals 6. So I'm plugging in -2 for x. And now what I'm going to do is solve this linear equation for the variable that's missing. So y. So 2 times -2 is -4. I'll add 4 to the other side. 6 plus 4 is 10. Negative y equals 10, so y must equal 10. So my y point, my y coordinate is 10. This gives me an ordered pair. So -2, 10 is an ordered pair. Very nice. And you can check. Plug this ordered pair back into this equation. You'll see it is a solution. I'll let you do that on your own. So the next thing I'm going to do is pick another random point. I'm pulling it out of thin air. I'm being a little bit clever about them, and I'll explain that a little bit later on. So I'm going to pick 0. 0 is nice. We have 2 times x minus y equals 6. So we're going to plug in 0. What's 2 times 0? 0. Alright, so we have -y equals 6. Therefore, y must equal -6. I just noticed I made a mistake. Go back to the previous one. You might have already seen it and you were freaking out. -y equals 10, and then I said y equals 10. I meant y equals -10. I'm so sorry about that. Okay, now that I've fixed that dilemma, let me go back to this guy. This one is correct for a change. Good job, Jen. We have y equals -6, so here we are. And our ordered pair is 0, -6. Actually, if you remember, I pulled this one out of thin air previously, where I said we could do the check, in which I plugged in 0, -6, and it did in fact work out, right? Alright, I'm going to try another one. How about 2? So, we actually seen 2 a little bit earlier, but we're going to go ahead and do it all the way through anyways. So we have 2 times x minus y equals 6, and the x we're plugging in this time is 2. So 2 times 2 is 4, and we got to get y by itself, so we'll subtract 4 from both sides. So we have -y equals 2. We have to divide by -1, so y equals -2. And so we have the ordered pair, ordered pair to -2. which we had seen earlier as well, right? We said that was a solution. So these are just 3 solutions that work, and I just randomly picked them. Now, I picked them specifically because I have a negative value, I have a 0, and a positive. Generally, that gives us a nice shape of a graph. You only need 2 points to plot in order to graph an equation. I recommend when you do it by hand to use 3. That way you can get the whole shape of it. Especially if you made a boo-boo, you'll notice it right away if you don't get a linear looking equation. So, taking these lovely points, we're going to go ahead and graph them now. So, draw a graph however you need it. I got one here. And we're going to plot each point. So, I don't quite remember my points. I think I had 0, -6. I had 2, -2. And let me take a sneak peek. -2, -10. Okay, so now let's plot the points. Doesn't matter what order you do it, just get them on there. So I got -2, so x is -2, so I go to -2. And y is -10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was a close call. We're on the edge of the map. And then we have 0, -6. So start at the origin. X is 0. We don't move. Stay there. Okay, y is -6, so we go down 1, 2, 3, 4, 5, 6. Plot your point. And then last but not least, we have 2, -2, so start at the origin. X is 2, so we'll go to +2. And then y is -2, so we'll go down 2. And now here's the cool part. We'll go ahead and draw a line. Oops, sorry, that's not the tool I wanted to use. I think this one is not quite, but it'll do. Okay, so there's our line. Now, it's very important that you connect the dots. And notice these arrows at the end of the graph. In case you can't see, this one has an arrow at the bottom of it too. So these arrows are telling us to continue on in this fashion. That way we know we're graphing all the solutions. So pretty much it looks like the same. Keep on going in this fashion. If you connect the dots with a perfect straight line, you could see, all right, probably 4, 2 is also a solution. And you could try and plug it in and see if it works. So you can start seeing where you could predict solutions. Now the fractions are a little bit more difficult, like 1/2. It looks like it's somewhere over there. I don't know. It's hard to see, but that's what the arrows are for, to say, okay, if you keep on going, there's more solutions. And that's why we have infinite solutions. So that's how we graph it. And this is your answer. You just want the graph. Finding the points was useful. It was a means to our end, but you don't need to really state them. If you're worried that your graph looks ugly because you drew it by hand and you don't have this nice graphing paper, you can just label your points. That way you can reassure your reader that you know what you were talking about when you drew this graph. It's just that your artistic skills are, lacking. If I didn't have this program, this would be squiggles all over the place. And that's it. So good luck with linear graphing.